Have you ever contemplated the intriguing possibility of traveling back or forward in time? Time, it's the invisible, omnipresent force that rules our lives. It's relentless, and yet it's also the most taken-for-granted aspect of our existence. But what if we could command time? What if we could leap forward to witness the future, or step back to relive the past? This is the enigma of time travel, a concept that has fascinated mankind for centuries. Time travel is not just a product of whimsical science fiction novels or captivating Hollywood movies. It's a concept that has been explored, debated, and theorized by some of the greatest minds in science. From the idea of wormholes acting as cosmic shortcuts through the universe, to the concept of bending space-time itself, time travel is a topic that challenges our understanding of the universe and our place within it. Imagine, if you will, a wormhole. These hypothetical structures are essentially bridges through space-time. If they do exist, they could potentially allow us to cut across vast distances in space or even time in a matter of moments. Now, while this may sound like something out of a science fiction novel, it's a concept that is deeply rooted in the science of theoretical physics. Then, there's the idea of bending space-time, a concept that was brought to the forefront by none other than Albert Einstein. According to his theory of general relativity, massive objects like stars and planets can actually warp the fabric of space and time. So, if we could somehow harness this power, we might be able to bend time to our will. These theories, as mind-bending as they may be, serve to showcase the limitless possibilities of time travel. They compel us to question, to explore, to push the boundaries of our understanding. And who knows, perhaps one day we might just unravel the mystery that is time. So time travel isn't merely a figment of our imagination, but a concept rooted in science. But how does it work? Time travel isn't just a plot device in sci-fi novels and movies, it's a scientific possibility. Let's dive into the fascinating world of theoretical physics and explore the scientific foundations of time travel. At the heart of this concept lies Einstein's theory of relativity, a groundbreaking idea that completely changed our understanding of space and time. In simple terms, Einstein's theory of relativity states that space and time are interconnected as a single four-dimensional fabric known as space-time. This fabric can be curved and warped by mass and energy, leading to the phenomena we know as gravity. But what's even more interesting is that this curvature of space-time could theoretically allow for time travel. Imagine space-time as a sheet of rubber. A heavy object placed on this sheet would cause it to bend or warp. Now, if we could create a tunnel through this warped space-time, a shortcut between 2 points in time, we could potentially travel back and forth through time. This tunnel, or bridge, is what scientists refer to as a wormhole. Wormholes, as predicted by Einstein's theory, could act as gateways to different times or even different universes. However, creating or finding a stable wormhole and traveling through it presents significant challenges. For one, we need to understand and harness exotic forms of energy and matter that can keep a wormhole open, which is currently beyond our technical abilities. Furthermore, wormholes are predicted to be microscopic in size, making them currently inaccessible for human time travelers. Scientists believe that advanced technology or a better understanding of quantum gravity could potentially enlarge these wormholes, but this remains purely speculative. So while the science of time travel is rooted in real, albeit complex physics, it's important to note that we are currently far from making it a reality. It's a captivating concept that continues to inspire scientists and dreamers alike, pushing the boundaries of our knowledge and imagination. So, the science suggests that time travel could be possible, but what does that mean for us? Just imagine, if we could travel through time, how would that alter our perception of reality? The implications and potential consequences of time travel are profoundly intriguing, and indeed, mind-boggling. Let's delve deeper into this fascinating topic. Right off the bat, we encounter a slew of paradoxes. The most famous of these is the grandfather paradox. If you were to travel back in time and accidentally or intentionally cause your grandfather's demise before your parent is born, you'd essentially erase your own existence. But then, who would have traveled back in time in the first place? This circular causality creates a logical paradox that has puzzled thinkers for decades. Now let's turn our attention to personal identity. If you meet your past or future self, who are you really? Are you the same person or two distinct individuals? How would time travel affect your sense of self and your place in the world? Furthermore, time travel raises profound ethical questions. Would it be right to alter past events, potentially changing the course of history? Could we justify intervening in the past to prevent future atrocities, even if it meant causing harm in the past? These are not easy questions to answer. And then there's the impact on our understanding of history and the future. Time travel could potentially turn history into a malleable, changeable thing, rather than a fixed sequence of events. Our understanding of the future, too, could be drastically changed. With the ability to foresee or even shape future events, we'd be living in a world where the notion of destiny and fate no longer holds any meaning. In the grand scheme of things, time travel could challenge our fundamental understanding of causality, of the nature of time itself, and of our place in the universe. It could render our conventional wisdom obsolete and force us to rethink our most basic assumptions. Time travel is a tantalizing concept, one that continues to captivate us and challenge our understanding of the universe. So, we've taken a journey through the fascinating world of time travel. We've delved into the enigmatic nature of time, a concept that is both intangible and omnipresent. We've navigated the theoretical pathways that scientists believe could potentially lead to time travel, a journey that took us through wormholes, black holes, and the intricacies of Einstein's relativity. We've also pondered the implications and consequences of time travel, the paradoxes, the potential disruptions to the space-time continuum, and the ethical dilemmas that could arise. Despite these complexities and controversies, time travel remains a realm of science that consistently ignites curiosity and fuels imagination. It's a topic that has sparked countless debates and inspired countless stories. It's a concept that has fascinated us for centuries, and will likely continue to do so for many more. The mystery of time travel remains unsolved, but one thing is certain: it's a journey that continues to captivate our imagination. Until next time, keep exploring the mysteries of the universe.